Hello, this is Kim Bjorkman, and I am going to share my findings regarding trends in percent MVC with muscular fatigue. In order to compare muscular recruitment between subjects or muscle groups, it is necessary to normalize EMG values to an MVC and report EMG measurements as a percent of MVC. In general, most literature suggests that as muscles are contracted to the point of fatigue, the motor unit recruitment will increase and therefore percent MVC values will increase. However, there have been some reports of percent MVC decreasing as submaximally contracted muscles reach the point of fatigue. The purpose of this study was to determine trends in percent MVC over time with sustained submaximal isometric contraction to the point of fatigue and to determine if reports of decreased percent MVC were valid. Because most literature indicates that percent MVC should increase with fatigue, the hypothesis was that we would see a percent MVC increase over time. There were 8 subjects who were all first-year physical therapy students at Regis University. To determine peak grip force and MVC, the subjects conducted a max grip test in standard position using a dynamometer set to neutral position. The peak force and EMG values for this test were recorded. The subjects then sustained an isometric contraction in standard position at 25% peak grip force until the muscles either showed signs of fatigue and the grip could not be maintained, or 300 seconds passed. Both peak EMG and exact force measurements were recorded every 15 seconds. All scores were normalized to the MVC and peak grip force as percent MVC and percent grip force. Statistical analyses of these data were conducted. Figure 1 shows that 25% peak grip force was maintained effectively throughout the course of the study. Figure 2 shows very slight change in percent MVC over time. The low R-squared values of the wrist extensor muscles indicate no correlation between percent MVC and the time. The data was very irregular, and percent MVC did not have a consistent direction towards increasing or decreasing with fatigue. The R-squared values for the wrist flexor muscles indicate a weak correlation between percent MVC and time. None of the data were strong enough to provide any profound insight into the typical patterns of motor unit recruitment. Because the data were so weak, I don't consider the hypothesis either accepted or rejected. However, because there was a weak correlation between the percent MVC of the wrist flexor muscles and time, it is appropriate to look at the trend for this data. The negative slope indicates a slight decrease in percent MVC over time. Recent literature suggests that this decrease in activity is possibly due to a decreased capacity of the central nervous system to produce a maximal excitatory signal. Knowledge of trends in percent MVC can benefit clinicians who are trying to monitor muscle fatigue in patients. Thank you for your time.